Hi everyone, welcome to today's edition of Migrating Enterprise Database Lab. For today, we are exploring running SQL Server on Google Kubernetes Engine. Previous option for running SQL Server on Google Cloud, which were SQL Server on Compute Engine and SQL Server on Cloud SQL, which is a managed database platform. The third available option for running SQL Server is to deploy it on Kubernetes Engine, which we are going to explore today. Before we dive in, let's talk a bit about why we want to or why we should run our SQL Server on Google Kubernetes Engine. The most exciting ability is the ability to run the server across various cloud platforms or in a hybrid on-premise or off-premise platform. What are some of the benefits of running SQL Server on Google Kubernetes Engine? Automated creation of cloud resources and application. Higher degree of automation is available for creating continuous integration and continuous deployment pipelines. You can also run the database on the same cluster as the application for better performance. To configure your SQL Server database to run in a Kubernetes cluster, you need to specify configurations using YAML files. For a database, you need a persistent volume claim to allocate disk space for your database running in the cluster. You also need a deployment configuration to define the Docker image, environmental variables, and instance resources. There are many Microsoft Prevails Docker image that are available, and you can choose the version that suits your needs and make sure you set the required environmental variables so that you don't end up in conflict. You can use license agreement to specify an initial SA_password and other configuration details. So check out the Docker Hub webpage for more information on the different Docker image you can use. As in a standard SQL Server configuration, you have the software, data, log, and tempdb in different physical volumes. So you would configure different persistent volume claim for each of them. And each persistent volume claim has a unique name, and the amount of disk space for each is also specified. Then you can now put all the pieces together in a deployment. The persistent volume claims are then added as a volume in the pod you are configuring, and the volumes are mounted using the mount property. If you configure the SQL Server container, it will also run in the pod. And you can also configure the required environmental variables in the deployment. The SA_password variable is being set from a Kubernetes secret. We all know that it is not a good idea to store sensitive data in plain text in a configuration file. So you can use secret to store the actual password and use the secret in the config file. The service configuration provides access to database running in the cluster. And if you want your database to have a public IP, you want to use the service type load balancer, which allows the database to be accessed from outside of the cluster. If you set the type to cluster IP, or if you didn't set the type properly at all, the service would only have a private IP address. This means the database would only be available from inside the cluster. And after you configure the various files you can then use the kubert command line interface to put them all together and deploy the server. Then you can deploy each of the YAML files with the command kubert apply -f and the name of the file for that configuration. Thereafter, you can also delete everything by running kubert delete. So that's an high-level overview of how you want to set up your configuration files and the reasons why you should run your SQL Server on Google Kubernetes Engine. So let's get started with this lab. As usual, the first thing is to start our lab. After starting the lab, then you want to open it in an incognito window. So open my console in an incognito window. I copy my password, click on next here, paste the password. So here is my GCP dashboard. Let's get started. So we've done all this setup and requirements. So the first thing we want to do is we want to create a Kubernetes cluster. And to create a Kubernetes cluster, we'll be using this command line, this command prompt, which is gcloud container cluster create Kubernetes cluster, then the zone, which we are using the US Central 1A. So what this command is doing is that we are we are using the gcloud container cluster create, and we are naming our Kubernetes cluster. We are naming it Kubernetes cluster, and this is the zone that we want the cluster to get deployed. So I will copy this. I'm just going to copy everything here. Then after that, navigate to my cloud share. So it's provisioning my cloud share machine, and after it starts provisioning my cloud share machine, it will also connect to my cloud share instance. So here we are. Then I paste the code to create our Kubernetes cluster. Don't forget that this is the name of our Kubernetes cluster, Kubernetes SQL cluster. And this is the code when you want to create a Kubernetes cluster on the GCP using the command line interface or using the Cloud SDK. So enter, then I authorize this. It may take a while for our cluster to get created. Typically takes around 5 minutes. I'll fast forward it and see you at the end. Here is our Kubernetes cluster. Our Kubernetes cluster has been created. So if after 5 minutes it's taking too long, you can just refresh your browser and you'd see the current state that it is. But typically it takes around 5 minutes to get created. So let's keep going. Uh, The next thing we want to do is want to get the credentials for the Kubernetes cluster that we just created. So with this command, come here and it's here. So what this command is going to do is just the same gcloud containers and then the cluster. Then we are getting the credentials for this cluster name, and this is the zone. So it has generated the endpoint. Then we can now test our connection by getting the nodes. So when you click on get nodes, so here are the nodes that we have, and you can see the status of each and every one of them. Their status are ready already. So which is what we want. So let's confirm if we've completed this. So this is complete. Next thing we want to do is we want to configure and deploy SQL Server into the cluster. So we've created our Kubernetes cluster. So now let's configure and deploy SQL Server in it. So the necessary code for this, for everything we want to create, is already done for us by default on this lab. So what we just need to do is we just need to go and clone the repo that the code is on and cd into that path. So when we cd into those paths, we can just get the code from there. But do a brief explanation of what those code does. So let's clone the repo. So this is the repo, training data analyst. You can see it's cloning the necessary information for us. Yeah, so we've cloned our repo successfully. Next thing we want to do is we want to cd into the path for that repo. So you can cd into the path, and when I open the repo, you'd see that this is still the same path as what is here. So just cd into the path from here. Then the next thing I want to do is I want to open my editor and show those codes from the editor. So let's open our editor. So to initialize the editor too may take a while. It may take roughly like 3 minutes or thereabouts. And fast forward it and see you at the end. Yeah, so it has finished initializing. Then we can open our editor in a new window. So let's wait for our editor to get opened. So from our editor, we can go back to that path that we used in our terminal. This is our terminal. Just open terminal. So this training data analysis courses DB migration and SQL Server and GKE. Let's go back there. From training data analyst, then we have the courses. Confirm that. Yeah. So from training data analyst, we have courses. After courses, we have DB migration. After DB migration, this is the SQL Server and GKE, and this is the major thing we are interested in. Okay. So the next thing is to explore each and every of those files. So for the volume claim files, so when I was doing the intro, we talked about the persistent volume claims for each and every of them. So there is one for the software, there's one for the data, and there's one for the transaction logs. And then each of them also have different names. You can see this, the base, the MDF, and the LDF. So depending on the name you name them, it does not really matter. This is one for the base, this is the data, and this is the log. So that's regarding that. So the next thing is this on the deployment.yaml. Okay, yeah, the deployment.yaml. So you can take a look at this deployment.yaml. This is where we specify the image that we are using, the image to the SQL server that we are using. This is the image. Then, and here, this from this 21, this is where we specify the environmental variables. And you can see our SA password where we use a Kubernetes secret to reference everything. So this is the name, this is the key, and we've already saved our secrets. Yeah, so these are just some of the environmental configurations. And these are the volume mounts that are referencing each of the persistent volume claims that we created. So you can see the MSSQL, the MSSQL LDF, the MSSQL this part, and everything are just from here. So you can see this, and this. And we also take a look at the take a look at the deployment also. So here are all those this here are the volume mounts, and here are the persistent volume claim, and this is the persistent volume claim for each and every of them, for the base, the MDF, and the LDF. So going to the service, so this is the service that we created, and like we said, you have to specify a type of load balancer if you want it to have connection to a public IP. So because I'm using a type of load balancer, it's going to create it and also create it with a public IP address. In the case where I did not specify this or I did not do this properly, it's going to create the database without a public IP. But because I want a public IP, whereby I can now connect to it through an external client, then I'm going to use the type of load balancer. So in case you did not put this, you would only be able to connect within the cluster and not outside the cluster. Okay, so that's for the three things. So that's everything we've done here. And after that, we can use the Kubernetes secret that we then run this command to create the Kubernetes secret that we created. So if you are doing this on your own, maybe doing deployment, and you specify a weak password, so it may throw an error, and then you would have to like change your password to use something that would actually work. But this password should work. It's so you can see I'm using a I'm using a number in between. So it has a capital letter, it has a number, it even has a special characters. So you can consider that when you're using. Yeah, so thereafter, I'll use I'll run this command to create the Kubernetes secret that I'm using. And in this secret, I've also specified this SA password. So you can see this SA password that SA underscore password, and I use as an environmental variable in the other one. I'm telling you that anytime you see this SA password, use this value, and that's what we are doing. So I'm just going to copy this and run the command before I begin the deployment. So, so it has created my Kubernetes secrets. And the next thing I want to do is then I can now deploy each of those YAML files that I created. So deploy the volume claim, deploy the um, MSSQL deployment file, and also deploy the MSSQL service. So just run that, deploy everything. So you can decide to run them one by one, just do everything together. It's fine. So it has deployed everything. So the next thing I want to do is I want to see whether the database is now ready now. So I can do that by using the Cobalt get points. And also take note that if you run this thing too fast, then the process would you'd still see it in running, and everything is not created. So you can see the status, container creating. So I have to like still wait a bit before I run the command again. That is so that everything has not been created fully. So you can wait for maybe 1 minute and run the command. I run the Kubernetes get pod now, and you can see now the status is already running, which is what we want. And this typically took 72 seconds from when I ran this. So just slightly above 1 minute, you can do that, and when it will be fine. So the next thing I want to do is I want to get the IP address of the database that I created. So with the Kubernetes get service. So let's see. And you can see this is the Kubernetes, the one for the cluster IP. You can see that there's no IP, there's no external IP address. But when we created our SQL, this MySQL server, and the MySQL server deployment that we used a load balancer type, you can see that it created it with a cluster IP and also an external IP address, and which is the reason why we used a load balancer as the type, as the service type. So we are good. You can take note of this external IP address. I just take note of it. So maybe copy it somewhere here. If you are using it for production, you probably have to save it somewhere that you'd be able to access it anytime you need it. So the next thing I want to do is let's check if this is complete. So this is complete. And another thing we can check is we can even go to the GKE and see if we can see some of these services um, just by using it. So when you go to your cluster, so here's the cluster that we created, this Kubernetes cluster. So you can see it here. And if you click on it through this one, you should be able to um, enter into it and see some more configurations. So you can see the external endpoints and internal endpoints. And for the secrets that we also use, you can also take a look at it. So this is the SQL secret that we created. We go into it. And this is where the password is shown. So you can take a look at, you can just play around all this and see them. These are just for what we created. So let's go back to our lab. So for task 3, we want to connect the SQL Server database to a client machine. So because we want people to talk to our database. So we create a client machine, we create a test server that we'll use to connect to our database. And let's see if we're able to connect to it. So what we are going to do is go back to our console from compute engine, virtual machine, create a virtual machine. So yeah, just some virtual machines that are there because of the cluster that we created. So let's create our test client. Click on create instance. So then I'm going to use this name, SQL client server, SQL server client. I'm going to use a container optimized bootfix. So let's use the name Qwiklabs specified. Then this region is fine. That's fine. So for the boot disks, change the boot disks. That is a container optimized operating system because typical dealing with container. Yeah. You can leave this as default and select. So you can also leave this as default and just create your client, your SQL Server client virtual machine. So we are naming it SQL Server client, and it's just typically a, a default settings for the virtual machine. Yeah, so you can see I've created our SQL Server client. And now we just need to SSH into it. So when we SSH into it, then we can now try to talk to our database. So let's wait for the SSH keys to get transferred. Yeah, so here we are on our SSH. So you can confirm if you've done this. We should. Okay, that's fine. The next thing we will start the container in an interactive mode. So to do that, we just run this command sudo docker run this. So this is just start the container in an interactive mode. And then so that so it's just all the necessary this is Docker image that we use and everything is on it. Yeah. So after here, the next thing we want to do is we want to try to enter into our database. And to enter into our database, you use this command, SQL CMD, then the IP address of the service that we copied the other time, which is the external IP address to specify it here. And this is just the password that we are setting. So I'll change this IP address to the IP address. So here's where I save the IP address. I'll just copy it. And go back to my SSH server. Enter. So now I'm inside the database so that you can see that I'm inside something. If you are not still sure, maybe I'm just inside another thing. Let's actually prove that now we are inside the database. So to do that, just the normal SQL Server command that we use with the execute SP databases to show the databases that are currently there. And don't forget that anytime you are running a command in SQL Server, you have to use Go at the back. So these are the default database that comes with what we created. So we have the master, the model, the MSDB, and the temp This is just it. So if you create a new one, it will also show you. We've shown that we could connect to our database and there's connection between both of them from the SQL Server client. We could talk to the database that we created using a Google Kubernetes engine. So the next thing, the final thing is just to round up. And to round up, you can just run this command on your Cloud Shell. So to delete the services that you created. So this is the YAML file we created. This is also the YAML file, YAML file. And you also delete your secrets. This is just to tidy up. So go back to your Cloud Shell and run this command. Run the four commands. So just copy it once again. So if you are unable to click into it, just like what I'm experiencing, you can refresh your browser. You can just reload it. Yeah, and there we are. So just paste the code, copy it to delete everything, and then everything will get deleted one by one. And after they are deleted, that's fine. So that's typically everything we want to do for this lab. And just a recap, we created a Kubernetes cluster in Google Kubernetes Engine. And we also configured and deployed a Microsoft SQL Server database inside the cluster. And we connected it from a client's machine. So in this case, we just created a test client machine and we were able to connect to it. So just the same way you can connect an external client and a client machine you want to connect to it, you can also connect that. But typically, you can also do a network peering for your database because you don't just want anybody from anywhere to just be able to connect to your database. So yeah, that's all. And thanks very much for staying to the end of this lab. This lab is pretty basic, but it shows how we can run SQL Server and Google Kubernetes Engine. And all the configurations that we also set are shown in the lab. So thanks very much for staying through. If you enjoyed this lab, give it a like, comment your thoughts in the comment section, and see you in the next series. Bye for now.